recap, right? Awesome. Let me actually share my screen. And just give me a second. Let me know if you can see it. Give me a thumbs up if you can see my screen. Can everybody see it?
I can see it.
Okay, good, good, good. Awesome. Okay, so today again, just like yesterday, we'll try and make this that's interactive, engaging. Questions please put on the chat. Like Akin said, this is really for all of us to learn, to share. Okay. Day one was about really understanding the basics of data science lifecycle, right? We started by discussing the importance of understanding the business objective and defining the problem statement, right? Very important. Okay, it's not just unique for data science. I think it cuts across the entire spectrum of creating solutions. We explored the various steps involved in acquiring data, cleaning data, transforming it, and performing some exploratory data analysis. Now, today, we'll take it a step further. Okay, we'll dive into exciting world of feature engineering. Many of you may have heard about that. Model selection, very important, very critical. Model development, many of you will be involved in that if you get into this field. And we'll be discussing how to create the best features to train your model and how to select the best model, okay, that fits the business requirement. Very important. That's where a lot of, you will need some sort of background to figure out, okay, this is the best approach or the best model. Now, of course, for your project to be successful and for you to demonstrate you understand and you've done this, okay, we'll develop a minimum viable product, okay, an MVP, to demonstrate the capabilities of the model. We'll also be discussing how to create a report for your stakeholders, right? And then showcasing those results or the findings of your project. Now, to top it up, I see some questions. We'll be talking about quantum computing. Very interesting topic. I would really love to get into that. That quantum computing is one of those sort of has been around, what's emerging, and maybe if you have some specific questions around quantum computing, sure, I'll be glad to answer those. But to get back, right, we'll be looking at one or two cool topics. Maybe one of them will be quantum computing to kind of discuss. I've chosen this topic because it seems to be relevant now. It's called generative, that's artificial intelligence and its capabilities. I'm sure you find it fascinating because that's where things like ChatGPT has come about. So without further ado, let's jump into it. So we've gone through this. Yesterday, we went through all this. So today, these are the topics, right? And then let's just go right into it. Now, so you've heard about feature engineering, okay? Yesterday we did cover that's exploratory data analysis, EDA. It's a very, very crucial step in any data science project. And it helps us to understand the data better. EDA will provide some insights into the data distribution, missing values, the outliers, and it helps really in defining the selection of the future variables that will be used in your model development. Now, features, they're really variables, right? So in talking about feature engineering, right, it really includes creating new features, right, from existing features to improve the model performance, right? So in other words, it's about transforming a sort of raw data into a format that is suitable for modeling. For example, if we take the loan prediction use case, right? We might have features like age, income, loan amount. We can create new features such as, for example, you can do, let's say, income to loan ratio, right? Or age to loan ratio, okay? This will help us, okay? It better captures the relationship, right? So in short, if you take EDA, okay, it's a crucial step, okay, for feature engineering, okay, because then you build better models. Now, one of the key things, right? So the way I look at feature engineering basically is this, right? You have existing features, okay? You want to create new features, right? These new features will help you in getting better performance from the model. So we've kind of, used that example, okay? The goal for feature engineering, okay, is always to create new features that will capture the important patterns in your data that helps the model make better decisions. So very important step, okay? I've gone to, for example, I've been called into some projects where they're struggling, and we have to kind of go back to look at the feature selection and say, okay, what are some of the key features? And that's when domain knowledge is so important, okay? I keep on stressing this, domain knowledge, because when you now talk to the business and you talk to people who know that industry very well, they can tell you, oh, yeah, this feature will be important, because from a purely data science standpoint, you might make some really good selections in terms of your features, but when you bring in your domain knowledge, it really helps. Okay, all right. So assuming, let's continue with our use case. Okay, so assuming you have these features, right? These independent variables, right? Which are really features. So in the context of the loan prediction based on customer behavior, what are some of the new features that you can engineer? Can we give like 2 minutes for folks in the chat to be able to kind of, yeah. Okay. Just put, yes. Yeah. Just put right. What could be some new features from these ones on the left. So you have income, gender, loan amounts, debt, marital status, education. What, from your perspective, what new features can you engineer? Let me just, type whatever you think in the chat. Let's see. Okay, I give an example. Income to loan ratio is one example. Okay, you created those from these independent variables. Okay.
Someone said region, credit score, average income by gender, race. Please change your chat to everyone and not direct. When you say direct, it goes to me. Just make it to everybody. Thank you, everybody. Health, okay. I see age.
Well, remember, you have to engineer it, right? So it will come from these independent variables, right? And then you can engineer something else, right? Okay, I see some attempts, right? Some, okay. Remember, the key is to engineer it from what you already have, right? So if you take the example I had, right, previously, I had like 3 variables. I had income, age, loan amount. And the example I gave you was that I can do something like income to loan ratio. Okay, that's it. That's a good one. Okay, you engineered it from what you had, right? Okay, great. So I'm seeing some good ones now. Income to marital status, loan amount to gender. Okay, the average income to education. Yes, these are good ones, right? Because they may be able to give you more insight, right? Because if you just look at the independent variables, it doesn't say anything more, okay? But when you begin now to engineer it, okay, you get a better insight. Okay. So good. So let me kind of show my own examples. Okay. One very, excuse me. One very good one is debt to income ratio. Okay. Helps. Okay. Loan repayment capacity. Okay. That's my own. Okay. Loan affordability. Okay. How do you calculate that? Loan to income ratio. Sure. Loan amount or term ratio. There is more. Why is this important, right? Because when you bring in domain knowledge and your data science cap here, then you'll be able to create these features that will help your model make better predictions. So you see, many of these AI tools we use, right? Okay, we don't just want to be consumers, right? We want to be able to say, okay, that's the output here. Why is it giving me this, right? And then make sure that if you're in this space, make sure you have access to be able to look at the features, right? That's where, when we do assessments, so for example, one of the courses that I teach, or kind of, is that being able to assess that's the explainability and responsible AI. This is one place that I look at. Okay, I say, okay, what are the features? Okay, let's look at those features, right? And so there have been many cases where I've told the engineering team or the data science team, go back and re-engineer this, because these features do not lend you to kind of getting the best performance, right? So again, that's why feature engineering is very important. Okay, so it's kind of like, that feature engineering, the way so again, to have had these descriptions here, just for you to get a sense why I chose these ones, right? Okay, for example, if we take one of them, debt to income ratio, right? If you just take the income, right? Okay, somebody may be making, more, maybe like 200,000 a year. Okay, that's good. Okay, but if you just take that, right, it doesn't give you an indication of perhaps if this person will default. But if you now look at the debt, right, then you'll be able to say, oh wow, even though this person makes a lot of money, but he or she has a lot of debt. Okay, and then that ratio now gives you a really good indication. Okay, make sense? So we need to be that place where we understand how to engineer these features, and it's going to really help when you begin to look at things like responsibility or responsible AI, explainability, which we all should be really I won't say worried about, concerned, okay? And very important in this space, those are the places where we need a lot of representation, okay? It's very passionate for me because when we go to those places, right, to those conversations, I'll tell you on the table there, it's not many of us, right? And this is troubling because if we're just consumers, right, then it's a subtle, what do you call it? Subtle way to kind of reprogram us to think a certain way, because we're going to rely heavily more and more on these AI assisted decisions. Okay, so you see why it's important that I'm extremely passionate about this, because if we don't get many of us in the pipeline, right, many of the designs and the models and the data sets will not represent us. And I'm speaking generally, right? Even if you take simple things like gender, right? Okay, for a long time, you know, because it's mostly men, young men, mostly Caucasians, right? There is bias already introduced because you bring in your bias in the way you seek out data. You bring in your own bias in the way you create models. It's intrinsic. You bring it in. Okay? But unless we have a way to forestall that, it's this to me is a huge challenge. And when we begin to see more of you join, get into data science roles, get into related roles, right? We'll begin to challenge this, right? And that's one of the things that I see huge opportunities. By the way, there is so much incentive now, right? So much incentive now to make sure women representation, minority, huge incentives, huge. Because one of the first things we look at when we say bias is how diverse is the team? How diverse is your data set? How diverse is, you know, that's one of the first metrics. So you're actually in a good place, in a good, it's a good time to be in this space.
Ekpe, let me chip in for a second, just to the larger community. I'm challenging us on this call. If we have younger folks, younger kids trying to figure out a path in life, share the knowledge you have on data science to them. You know, most of us are getting younger, right? Whether we know it or not, Ekpe and I, in a few years, you know, I'm sure some of you that knew me like 15, 20 years ago, I didn't have white beards, right? Ekpe too, you know. So the truth is that we have to think beyond ourselves at this point, really, because we need the younger folks. Ekpe kept saying to us, data is the new oil, right? That's why a company like Google, Microsoft with their Bing product are valued at trillions of dollars. Let's put it in perspective. The GDP of Africa last year was about maybe 2-point-something trillion dollars, right? The GDP of California, the state, last year was about 4-point-something trillion dollars, right? And think about it, Palo Alto, all these big Silicon Valley companies, it's really data-driven. Even Tesla is a software company that happens to manufacture cars because all the data points they use, right now they're data mining it. So it's a massive thing for us. So this is so important, really, because as many of us that can position ourselves to be intelligent consumers, to be early adopters, and to be the domain experts to start building solutions. And honestly, I personally have a passion to push a lot of our folks to think and say, this is a new field, fair game. Don't let us get to a point we totally depend on. I love our Caucasian community. We love their model. I love my Indian community. We love their model. My Israeli community, I used to work in Tel Aviv myself. We love their model. We just want to be part of that process too, to develop a similar effective model to make sure, one, as a community, we are successful. As a country, North America, US, Canada, we are equally adding much value. We bring something to the table. We don't want to consume and people just, well, what do you guys have to offer? No, we are part of the conversation because we have our folks building similar models, contributing to the scientific community to develop things. So I challenge all of us, really, don't take it trivial. Find a way, especially the younger folks, if you're on this call, you're younger, this is a good field to kind of spoil yourself. And in 5 years, you'll be the pioneers, you'll be making 500, 400,000, whatever number it is. I want to be position you to be successful. Very important, you know. Back to you, sir.
Yes, yes. I think again to just really echoing that, right? You know, apart from getting this knowledge, we have to be at the table. We have to have that pipeline, right? And I think that's one of the reasons why I really, very passionate. And actually, you know, when we started talking about this, it's like, yes, we have to do this, right? We've seen this happen for the demographics. I think it's time we begin to push to be so. Okay. All right. So again, to future engineering, we've seen how important it is. We've seen how if you don't get it right, even though you have the best implementation and so on, but if you don't select the really good model and features, right, your result may not match or map what you're trying to solve. Okay, now model selection is huge, right? It's an important step. Okay, of course, every step is important. So again, but model selection is where you can really showcase that you know what you're talking about a lot. Okay, it can be very confusing. Okay, because especially if you're not familiar with the technical, you know. But let me kind of, simplify it, right? Think of model selection like trying on clothes in a store, right? Just like you wouldn't buy the first outfit you try on. You always want to use, you also want to use the first model you come across. You don't want to use the first model you come across, right? You want to try out different models, right? To fit your problem. You have to try a few different options to see what works best. So first, you have to know the problem you're trying to solve. That's why even if you don't have the domain expertise, if you don't have a clear understanding of the problem, make sure you do that. So in this case, we're trying to predict loan default, right? So let's focus on that. You clean your data, right? Just like you can't cook a great meal with spoiled ingredients, you can't make accurate predictions with messy data. You take a closer look at your data, okay? It's kind of like figuring out what makes your consumers tick. What are they really trying to solve, okay? And so we use EDA to understand relationships between the different variables, right? Now, you want to pick a few good models, right? So imagine you're at a restaurant, for example, and with a menu the size of a, let's say, phone book. For many of you who know what phone book is, right? To make a decision, you need to narrow it down, narrow the options, to a few dishes, that you can then try out, okay? Same thing goes with models. There are so many models. The process of narrowing it down is very, very important, because for the most part, you're not going to be building models from scratch. You're simply going to be choosing which one to try out, okay? Now, testing the model, right? It's like trying a bit of, each of these dishes that you've narrowed down, right? You want to see that which model, does the best job of predicting the loan default. And then finally, you choose the winner. It's like saying, okay, I finally found the dish that I like best, Now, of course, you may need to tweak it, okay? You may need to tell the chef to add a little bit more salt or make it, for many of us, if it's like steak, we don't want raw or rare or medium rare, we want it well done, stuff like that. Making some of those changes to improve the performance. Same thing in that model selection, okay? So that's really it, okay? Those are the steps you want to follow, right? You want to keep on trying things, narrow it down, try things, and then you make the best selection, okay?
I just wanted to say one thing. The way you explained it made it sound so simple. And trying out clothes, if it doesn't fit, I replace it. So I'm looking forward to that simplicity of.
True. What I do think, again, to maybe it's also because of my academic background. It's really many times we tend to make things complex. Okay, make it sound scary and complex, and it's, for me, that is not a good way to encourage people to join something, right? You want to simplify it. Okay, it doesn't take away the need for you to do the work, right? But if you can simplify it, there is the acronym case, keep it simple and stupid. It really works here. Yeah. Make things simplified, okay? And so again, when I try to explain these things, is to simplify it, because then if you get the picture, which, by the way, if you use these things for an interview, trust me, you will blow your interviewer away, because they're like, wow, you not only understand the salient point, but you can actually convey it, which is so important. Yeah.
Thank you.
Awesome. Okay, so now the steps, well, we're talking about model selection and development. Okay, for the most part, none of us is going to be building models from scratch. Trust me, those have been done a long time ago. Okay, what you're going to be doing is selecting, like narrowing it down, selecting and trying them out, okay, and tweaking them, right? And then you select, okay, this is the right one, okay? So if you take the loan default prediction, what the officers really want, they want to predict, they want to be able to predict the likelihood of loan repayment. Okay, so here's the process, right? The process will involve dividing your data. So first of all, you've defined the problem, okay? It's to be able to predict the likelihood of loan repayment. Okay. The next thing is you want to be able to divide your data into train and test, okay? And there's, you can do, 70-30 split, 80-30, sorry, 80-20 split, sure, whichever works. So from the same data set, divide it, okay? Then you want to select a suitable model. We'll kind of focus on number 3, just a little bit, but, select a suitable model such as, let's say logistic regression, decision tree, random forest, support vector machines, whatever, okay? There are a few very, very popular ones. Sometimes you can go wrong, okay? So training the model, you have to use your training data set, and then you evaluate the performance using the test data set, and you refine it if necessary, and then you finally deploy it in that real world, So in many cases, an application, or you deploy it into some sort of production. So again, I like to use some illustration. It's like you're creating a dish, right? For the precise ingredient measurements to tasting, okay? It's like, sort of taste testing and the final presentation to customers, right? So let's go through it using an illustration, right? So imagine you're a loan officer, right, at a bank, and you're trying to decide whether to give someone a loan, right? You want to make sure that the loan will be repaid, but with so many applicants, it's really hard to keep track of who is trustworthy and who is not, So that's where this loan default prediction comes in. It's like having a crystal ball, right? That can tell you the likelihood of loan being repaid. So you split the data, right? It's like a chef, for example, carefully measuring the ingredients to create a perfect dish, right? We want to be precise when it comes to dividing our data. We want to split it into two parts, right? A training data set and test set. The training set is like a chef's kitchen, right? Is where we train our model by adjusting those parameters to get the best result. The test set is like a taste test, is where we evaluate the performance of our model to see if it's ready for prime time. Okay, now let's go to choosing a model. Now there are so many models to choose from, okay, and just like different chefs have different cooking styles, right? Each model has its own strengths and weaknesses, right? For example, logistic regression is like a classic chef, right? It's simple, reliable, and it's always a crowd pleaser, okay? Now, decision tree is like, I would say, an experimental chef, You can create some unique solutions, but sometimes, the recipe might be a disaster, okay? Random forest is like a team of chefs, right? Combines the strengths of multiple models to make a better dish. Now, support vector machines is like a sous chef, They can handle complex recipes and can make the dish, they execute it perfectly. So you see, different models, simple, safe to sous chef, right? Now let's go to training the model. Now it's time to get our hands really dirty, right? We use this training set to train the model, right? It's fitting it to the data and adjusting the parameters to minimize the prediction error. It's kind of like a chef adjusting the heat on the stove to get the perfect texture, okay? You're training it, right? So that's kind of my own analogy. You're cooking something, you adjust the heat because, if you just fire it up, you'll burn. The food may, so much fire, but the food is going to burn and you've not really cooked it, okay? So it's that training, okay? Now, of course, you have to evaluate it, right? Once you're done with the training, you bring it to a test person or a tester, right? We use it to evaluate the performance, right? Like calculating things like, the accuracy, precision, recall, and so on, right? It's like a test in a cooking competition. The result will determine if our dish is a hit or a miss, okay? Very important, okay? So you've evaluated it. Now you need to refine it. You select one of them. So you need to refine it, okay? If the results of the test aren't what we're expecting, right? We can refine the model, right? Maybe it's kind of like, maybe you need to add more ingredients, more salt, more pepper, okay? It's like you need to, like, you may add some additional features, right? And this is also where we create a lot of value, because we can say, you used some good features, but let's bring in more features here, okay? Or different. So again, it's like a chef that adjusting the dish after the customer has given feedback, okay? Like, okay, I like this dish, it's really good, but it needs more salt, or it needs more of this, right? It's kind of like that. When you're happy, and the customer is happy, then, deploy it, okay? It's kind of like you've selected the model, you've refined it, you've tested it, and it's now ready to be deployed in the real world. It's like a chef now saying, okay, go serve this dish to the customer. And then, the customer is happy. Okay. That's the process. Okay. Nothing crazy about it. Okay. It's, of course, the devil is in the details, and making sure you do the right things. Yes.
Sorry, there was a question, and I'm sure probably you would address it. The question is two things. First is there a site we can pull this model from and start fine-tuning it? The second question was, do you think there's a difference between testing your model and evaluating your model?
Yes. Okay, let me start from the second one. Okay. So the testing, right? Remember that the evaluation of your model is you've already trained it now, okay? You've trained your model, you use the test, right, to do the evaluation. So again, testing, is probably similar to evaluation, right? Because use your test data to do the evaluation, right? So we typically call it evaluation. We typically use testing when it comes to DevOps, right? DevOps. But for machine learning and for model development, we typically use evaluation, because you're evaluating the performance. Okay, so it's similar, but the right terminology is evaluation for model development. Testing usually be for DevOps. Okay, so just same things for the different pipelines or different ops. Then for the first question, yes, there are many sites, and I can send you some links where you can, many of those models can be exposed as APIs for you to leverage to train or to evaluate. Okay, and so if you have your business problem and you have some data, okay, your data may not be representative enough, and sometimes you usually have to go source for data, right? You need to go buy data, or source for data. So most times you may not have a complete or good enough data set to solve a problem. However, for your initial developments, okay, you can use sort of the open source data sets to build your initial model. And I can send you links. Kaggle is one of them. GitHub has a lot of that. Okay, there are a few recommended sites, and I can send you those links, afterwards. Yeah, very, very good question. And you leverage those when you're developing your initial model. models.
Somebody posted a question, evaluating for accuracy or to know if more ingredients like Maggi needs to be added or reduced subsequently. Okay,
Yeah.
we'll take that.
No, but that's correct. Okay, the evaluation, you've done your training, and then now, the chef now is like, okay, let's evaluate it, for whether there's enough salt or Maggi or, and so on. So yeah, that's really true.
Yeah.
And the cool thing is that the brain, you can map, the best way sometimes to retain things or to record things is to map it to things you already know, right? So that's why using these examples I find to be very effective, right? Because I can remember that, okay? I can remember how to cook because I do that. So I map it now to this complex thing, and then suddenly it's not so complex. Okay. So again, those are just what I found. Okay. Now, we won't be able to, there's no way we'll avoid looking at some of these models. Okay. And again, I promise I won't go into the huge or the deep, details, but supervised and unsupervised learning are the two fundamental approaches in the field of machine learning. Okay, and again, so machine learning is, that the way I look at it, right? The buzzword is artificial intelligence. When we advertise, we say data science. When we do the work, is really machine learning. Okay, so the buzzword is artificial intelligence, right? When you advertise things, it's data science. When you advertise to get people, data science. But the real work is actually machine learning. And so, because this model. So, so in the context of loan default prediction, supervised learning is used to predict the likelihood of the loan repayment based on labeled data. The outcome variable is repayment or default. Okay, it's known. Okay, but on the other hand, unsupervised learning that is used to identify patterns and relationships in data without some sort of predefined set of outcomes. Now, both approaches have their own advantages and disadvantages. You need to choose the right one, okay? And so, very important, okay? You have to, most times, at least for the classical machine learning, okay, these are the two, okay? There are types too. Now, I really love this slide here, or this picture, because for me, it summarizes it, right? For your typical classical machine learning, there are two branches. One is supervised, and the other one is, unsupervised. When your data has already been pre-categorized or is numerical, then it's supervised. So that means you will definitely choose models that are in the supervised category. If your data has no labels, and there's no way, you don't have any, it's not labeled, okay, then it's unsupervised. Now, if we go to the supervised category, if you're predicting a category, right, then you're looking at classification. If you're predicting a number, then you're looking at regression, okay? So you can use this now to say, okay, what are the classes of models I should be looking at? It's by, first of all, you understand the problem you're trying to solve, then look and see if it fits into supervised or unsupervised category. Okay, so this slide helps. Okay, and then if you go to the unsupervised side, right, if you want to divide by similarity, okay, that's clustering. Okay. If you want to identify sequences, then that's association. Okay. If you want to find hidden dependencies, that's dimension reduction. So for example, recommendation is a good one for dimension reduction. Okay, you're trying to find dependencies. If that's let's say Akin likes to watch Western, and I am very similar to Akin, then that means you can recommend Western movies to me, for example. Or I'm just picking a name here, Jubril Bello, if he likes Nollywood, okay, and Akin has similar taste, then that means you can recommend. So, it's that kind of thinking. Okay, it's not super complex, right? That gets us there. Now, some exercise. Now, again, I don't know how to do this. That's in the interest of time. I don't want to break out into sessions, but these are some simple use cases, right? Based on what you know now of supervised, unsupervised, different.
Yes. I think it's possible to do a quick breakout section. We can make it like 2 only, okay, so that everybody can just talk about this particular one. And yeah, folks, I would paste this to the chat group so that you guys will see it. So tell us what you want us to do here. So I would expect, is it going to be like, is it supervised or unsupervised? Is that what you want us to classify this?
No, that's classified as that's get to the level of that if it's regression, if it's classification. So discuss first if it's supervised or unsupervised. But what I want to see here is that you pick the right one. So if it's classification, put classification. If it's clustering, put clustering. So there's a sequence. There's a way to get to the right one. So if you look at, for example, spam filtering, do you think it's supervised or unsupervised? Then you now select the right model, right? Okay. So what I want to see is whether it's classification, regression, clustering, dimension reduction, or association.
Okay. So ladies and gentlemen, I'm going to put us into, let's do 3 groups real quick. Then we'll come back in 5 minutes. I think 5-10 minutes. How long? How long do you need, Ekwe?
5 minutes.
Okay, let's do it for 5 minutes. We'll just do like a group. We'll just do like a team thing. Let's do 2 groups then so that we're quick. All right, sure. Let's do that quick. And folks, please don't bail out. Just try and get the concept. All right, let's go. All right, thank you, everybody. Welcome back. Let's keep everybody else on. All right, cool. Thank you, everybody. Welcome back. Welcome back. And for those of us that build out, all right. So I believe you've all assigned someone to present on behalf of your group. So if you are the one presenting on behalf of your group, just kindly raise your hand so we quickly, let you all talk through what you found, and Ekpe, back to you. If you are presenting on behalf of your group, let me know, raise your hands, and I will unmute you. Let's do that real quick, please. And just tell us what your results were real quick, straight to the point. Are we ready? Who's presenting? Can you raise your hands, please, so I can see you? Thank you.
Who else?
I apologize. I don't see the people's hands.
You may have to scroll. Let me see.
Okay, let me see. Okay, I
Okay.
see India. Okay. All right. Over to you, man.
All right. So for the first one, we went with supervised classification. The second one, we went with unsupervised clustering. The third one, we went with supervised classification.
You mind say what they just map it? Tell us what it is and what.
Okay.
It's difficult.
I kind of number them 1 to 7.
Hold on. Yeah.
Let me share my. Yeah. Let me share my screen. It's taking some time, but hopefully it comes up. There we go. Just
not the screen.
Yeah, it's coming up. Just it needs to load it, and then okay. Let's see where are we.
This one.
Okay.
Yeah.
All right. So spam filtering, we went with supervised classification. Analyze web surfing patterns, we went with unsupervised clustering. Fraud detection, we went with supervised classification. Stock price forecast, we went with supervised regression. Stock price. Market segmentation, we went with unsupervised classification. Medical diagnosis, we went with supervised classification. Recommended systems, we went with unsupervised association.
Okay. Next group.
All right, go ahead, Anthony. Thank you, NDO.
Yes, hello, thank you from group 1, we went with, for spam filtering, we went with classification. Analyze web surfing patterns, we went with association. Fraud detection, we went with classification. Stock price forecast, we went with regression. Market segmentation, we went with clustering. Medical diagnosis, we went with clustering. Recommender systems, we went with reduction.
Okay. There were 2 groups, right?
I think there's one more group, but I think we can just continue. Thank you, NDO and Anthony. But Ekpe, we can continue, so we can.
Okay, good.
Thank you.
All right. Well, for the most part, right, I think most of us got it. I think for the most part, yeah, spam filtering, yes. Okay, it's classification, right? You're saying spam or not spam, so you want to classify. Usually patterns is a sequence, okay? So analyzing web surfing patterns, it's usually associative. So that's kind of, and then for fraud detection, yes, it's classification, it's fraud or it's not fraud. Stock price forecast is a number, okay? Usually numbers, so it's regression. Market segmentation, yes, it's clustering, it's unsupervised. You're trying to find associations or similarity. Medical diagnosis, supervised. Regression, because you're trying to get to a precise diagnosis. In most cases, we had some conversation around whether it's classification or clustering. There could be nuances there. And in some cases, you may need a combination. You may start from clustering first, and then you eventually get to regression. So again, these are not sort of entirely black and white, but for the most part. And then, of course, I mentioned recommender systems, yes, dimensionality reduction. Okay, perfect. All right. So good job, guys. Really appreciate the participation. Okay. So for our use case then, what is the category for our use case? We don't need to break out into groups. It's just, is it supervised, unsupervised? I think most of us will agree that it is supervised, right? Any objection in that? Okay, the chat is disabled. That's fine. Okay.
Is enabled back. Okay,
so yeah, just put in the chat if you can, but let's move on. I think it's pretty straightforward. Okay. Now, is it classification or is it regression? I think it should be straightforward too, right? We're saying if the loan will default or not. So it's classification, okay? Okay, and again too, right. There's a bit more, yes. So good, I like everybody's responding. Now, one of the key things, once you arrive, right, you can then choose the different algorithms, right? Okay, so the list here is not exhaustive, and for sure, we're not going to go through this, but things like the problem size, the data size, you know, the imbalance in the data, and the number of features will also influence which particular algorithm to choose. But you see the steps to arrive here. At least you're narrowing it down, and you can then choose the right algorithms. And for the most part, right, you're not going to be building these things, right? You're going to leverage them. Okay. Okay. Let's go to implementation, right? Sorry, to the plan, right? So you've gotten to this part. Your group you've done everything. You have your data, you've cleaned it, you've chosen your model, and you're now ready to build the MVP. Remember, your MVP is basically saying, okay, I'm just going to build something, you know, quickly, you know, that to bring to a working solution, so that you can demonstrate the viability of the model, okay? And the plan is very crucial, right? Because your stakeholder is going to say, okay, I approve of this, or let's give you, you know, $750,000 to go build it, right? And so this exercise here, I know we don't have time, but maybe we can, because this is one exercise that I think will really help. But I'll default to you to see if we can do this. There are two colors here. One color is sort of the main milestones, right? Okay. Then the lighter ones are that's the activities within those milestones. Now, maybe we can do this as a group, okay? You know, maybe we don't have time.
I think we can do it. We should do it as a, so my understanding is for each of those big categories, the lighter green are the subcategories, so they should align it to each one, right?
Yes, but first of all, you have to get the sequence of the main one first, right? The green, there are 4 of them. What is the sequence for
Got it.
the ones, right? Then you can pick one and say, okay, for this one, these are the sub tasks. Yes, and
Yeah.
they have to.
I think it's a great exercise. And team, if you guys agree, we should do a quick exercise. Give me thumbs up. I think those are the meat of this whole program. Give me
Yes.
thumbs up if you guys agree with me. We'll make it quick. It's a group. We'll make it maybe 2 groups this time around.
2
I need
groups,
thumbs up.
5 minutes. Yeah.
Yeah, we do 5 minutes, 2 groups. So let's recap again. Align the sequence of the thick green first, right? Then the lighter green, map it to the sequence of those 4. Let's do it quickly as 2, because those are the meat, really. All right, let's do that quickly. I'll send this to the WhatsApp group again so that we can have access to it. And let's get started. 2 groups. Let's go. I think we can keep the formal groups. It says open room, so I don't need to do it twice. Let's just do it. All right.
Yep.
It's open again. Welcome back, everybody. Let's see. Sorry. Okay. I think we should be good now. Okay. Sorry about that.
That's fine. So again, I hope that was a good exercise. I think it's really important. The goal was to sort of, to arrange this, milestone 1, 2, 3, 4, and then so on. So do we have the two groups, just 30 seconds each to kind of
Yep. Can you guys show, raise your hands to know the people that are presenting for your group real quick so we can have them quickly present? Let's go quickly. Please raise your hand so we can see you real quick. Can you please just raise your hand so I can see you?
So we have one. Andy is there. And who else?
Okay. All right. Go ahead and present. Thank you. Andy, please.
All right. So in ascending order, we have data collection, we have data solution, we have deployment, and then lastly, we have monitoring and maintenance. And then for the little tabs, we have 34. Under 82, we have 34, we have 19, and we have 3. So we have 3 under that column. Then under data selection, we have 77, we have 16, we have 8, we have 27, and we have 4. And under that, we have, we have 77, 16, 8, 27, and 8. Then under deployment, we have 45. And then also we have 65. And the last one, monitoring and maintenance, we have 41 and also 23.
Thank you. All right, let's on to Doe. Go ahead, Doe. Thank you, Andy.
All right, we're going to keep it simple here. What we have, we just pick the number and match the number to the numbers. So like data collection and preparation 82, we have 34. We have 19 and we have 27. Then for model selection and deployment, we have 3, we have 65. Then for deployment, we have 27, 45. And for monitoring and maintenance, we have 41, 41, 23, 16, 77.
Thank you.
All right. Thanks, everyone. I think, we've made good tries here. But my own was similar. Okay. Again, I think I should have had almost like, but it's 34, 19, 27 for 82. 3, 8, 77, 16, 65, 45, 41, 22. Now, again, the idea here is that, of course, one's interpretation might be slightly different. As a group, you will come up with this plan, and that's what you're going to present to the stakeholders. So again, it can be subjective, okay? It depends on the use case and so on, but good exercise here, guys. Thanks. And so this is what I have here. For data preparation, you collect the data, you clean the data, and then you split. For model selection, you select the appropriate machine learning algorithm, you develop the predictive model using training data sets, okay? Evaluate it, refine it. Then for deployment, you set up that environment first, and then of course you deploy. And then monitoring and maintenance. Yeah. All right, cool. All right, so again, we have maybe 17 minutes more. Maybe we'll go over by 5 minutes. Okay.
Yes.
But I wanted to kind of spend just a few minutes to talk about some, some cool, 1 or 2 cool topics, right? Because again, I think it's part of what we're doing here, right? So GPT assist, okay? Because that's one of the cool topics now, right? And I want to make sure we're aware, right? And so I took this, so I did this. I put this that in GPT. I said, okay, fine. We're now close to the end of the second day, right? We've thought about this. What I wanted ChatGPT to do is to generate a stakeholder report outlining the key benefits and impact of the loan default prediction solution, and then the MVP plan. Now you fed it some information, right? That's where prompt is very important. Prompt engineering. What am I trying to get at, right? So let's see the results. Okay, now I apologize. This might be small, but I wanted to get everything into one screen, right? And cool enough, Chat GPT generated, it said, okay, loan default solution, introduction, key benefits, impact, implementation plan, and a conclusion. Now, you should be able to refine this by prompting it more things or by bringing some domain expertise into it. But you see how you can use your knowledge of the data science life cycle and your domain knowledge to kind of refine this, right? And make it more and more client specific, right? And so what I would say is that when you combine your domain knowledge and your data science life cycle knowledge, right, then you can produce the reports or whatever it is that will resonate, okay, and be more impactful, okay? Because what I've seen sometimes is stock generation of things that are not really hitting the salient points, okay? Here's another example. Many of the chat bots and the bots we use, right? Okay, you can capture. They are being trained on a lot of the interactions that between customer and the customer service rep, and whether it's chat or call, those things they're always recorded. In fact, they tell you, okay, it's recorded. Why? They use it to train. Okay, so for example, this here, this here is a transcript. Of course, I won't read through everything, but it's a transcript of a chat between a customer and a customer rep. Okay, and it's okay. Now we can take this and say, fine, let's generate some insight here, right? And some of the cool prompts that I want to, can you extract some key information from the outcomes, right, and decisions? Can you put it in a tabular form, right? Can you, rate 10 of the outcomes in terms of price, sensitivity, discount, customer experience? There's so many things you can do, even just with this application. Why? Because it's being trained on this vast amount, billions of tokens, right?
Okay. Yes. Just a comment. Do you mind? Can you go back to the first one, the real life case study we went through? Can you go back there real quick?
Yeah.
Thank you, sir. The first one, not this one. Sorry. Yes, this one. Yes. Is it possible to copy and paste this for us so that, sorry, the prompt before this, sorry, not this one.
Sorry, before this.
I want everyone to leave here and say, hey, I did this and we got the report. Can you copy and paste this to the group? And I want everyone within the same two groups, if you don't mind, copy and paste this into ChatGPT, anyone that has access, then you guys see the result. Copy and paste it into a Word document right now, real quick. We'll do it like for 5 minutes only, and we'll come back. Ekpa, is that okay? Do you mind?
Sure. So let me copy this and whatever.
You can paste it, in the WhatsApp chat. And everybody, anyone that has access to ChatGPT, just paste it there. Then present, show us, view, let us see it in your group. It shouldn't take you more than 2 minutes, really. Just copy and paste it to ChatGPT. You will see the report because we prompted this. This is the domain knowledge that HIPAA has and say, oh yeah, give us the result, right? So I want us to see it in real time. And I want you to leave here with the ownership to say, you came up with a finalized report based on all the activities we've done in this last 2 days workshop. So own it and make it your talking point at the end of the day. So we're going to copy and paste it now, get back to our group. Honestly, you'll be surprised. It won't take more than 2 minutes once we have it copied to you guys. All right. And we'll bring you back in the next 5 minutes. All right. It's straight to the point exercise. Don't overthink it. Copy and paste it. Okay.
Okay.
All right. Oh, you copied already?
I pasted it in the WhatsApp.
Okay. Thank you so much. All right. Let's do that real quick. I'll open the room again, the same room. Let's do it real quick, everybody. Thank you.
Okay. All right. So I know, so again, so I'd like to see your experiences, okay? I can share mine, but also I'd like to see what you all got. Mind you, right, the way your outcomes from ChatGPT work is that, one, it learns your style, okay? It learns the types of prompts you've made in the past. So if you have some history, right, it's learning it. You know, that's why you typically will log in, right? So it knows who is prompting, okay? It keeps a record of your methods, your style, your topics, right? And so your responses for the same thing might be slightly different. And that's where your ingenuity, your creativity comes in, your individuality, and how you prompt it. So for example, let me share my screen. Mine, you know, mine, can you all see my screen?
Yes.
Okay, the same prompt, right? I basically said, hey, we've been doing this for 2 days. Generate a stakeholder report outlining the key benefits, impact of the loan default prediction solution, and the MVP plan, okay? And mind you, it also has a record of what I've been working on, okay? So it's going to say, okay, fine, I understand what you're talking about. Now, if it's just from start, it will leverage this, okay? So what it did was, okay, it says, okay, this, you know, it gave some intro, said these are the key benefits, okay? Of course, improved risk, increased profitability, and so on. Now, this here, right, can be, I would say, generic, okay? What you want to do is to make it more precise to the use case and to the client. That's where what you say here, you know, will be very important, okay? Because now it makes it unique, okay? So let's say I can improve this vastly, right? By improving my prompt, and that's where prompt engineering is going to come into play. In fact, it's going to be one of those things that we'll be talking about in a few months, you know, okay? And so one of the, you know, one conversation Akin and I, you know, have had is we may need to have a seminar to really talk about this, you know, this sort of chat GPT and so on, okay? And so it gave the key benefits, it gave the plan, okay? It says this is a plan. You can now take this plan and you can work it into a Gantt chart and, you know, show that maybe a flow chart or a Gantt chart or you know, waterfall, whatever it is. That's where domain knowledge comes into play and so on. And then get conclusion. I can modify these things and so on. So really, it's important that we, like Akin said, right, and I've been saying, we want to be the early adopters, not just consumers, but also be at the table and see how these things can help you, you know, in your job and so on.
Thank you. And guys, if you don't mind, give us extra 5 minutes. I know we would like to see what your group presented, just to kind of see 1 minute quickly, raise your hand. Let's just see what your group presented. Because think about it that, okay, this is the final output. So I want you to take ownership of this 2 days experience. Believe it or not, somebody can pitch this to get a entry basic level experience in data science. That's the reality. All right, go ahead, Abby. Let's quickly see it. Go ahead, please. Feel free to share. Thank you. Excellent.
Can you see my screen? Yeah.
Yep.
Yes.
Yeah. So this is what we got in my group, and Dr. Ekpe, unlike yours, right? You provided the background information, right, of the training before prompting, right?
Yeah.
So what I did to see what the difference will be is to just go ahead with the prompt without providing the background information,
Right.
Of course, it came up with some generic thing that could still be aligned with some of the things that you got, but may not be specific, right, to the situation. So, I mean, it's great, right? Because I've been using this now for a month, you know, in my job, and it has made life so easy, right? Because when instead of going to Google to search information to see, okay, this risk I'm looking at, how can it be exploited as a cybersecurity professional? I type it in chat GPT, give me all the options. And I'm now able, based on my knowledge, to narrow it down to my specific situation. And it's been a great wow effect. So it's good.
Absolutely. Absolutely. Very powerful.
Thank you so much. Excellent job. Let's go to the next group. Thank you, sir. Dove, please go ahead. Go ahead, Dove.
Can you see my screen?
Yes, sir.
Okay. What we did was that we did the first one. Let's see. Okay. Yeah, this was the first one we got. I wanted to copy, put it on the Word document, but we didn't get a chance to do so. I don't know if everyone can see my screen.
Yes.
So apparently it didn't give me the same format as the other two, doctor and the other gentleman. So this is what we got. So what I did was someone asked for it to be regenerated. Let me see if I can put that up.
You know what? You know why? It's because you really tell it what to do.
Say that again.
Yeah.
You didn't really tell it what to do. You didn't.
Okay. All I did was just to copy and paste.
Yeah. So what it did is it just realigned your language, but you didn't tell it what. So remember the last word, and you see where prompt engineering is. Ekpe, is there going to be like a future career for people that are just prompt engineers?
So I'm telling you, that's going to be the next frontier. There's going to be that's the roles and the jobs where it's really prompt engineers, because this is what is going to move this, right? You know, we're already seeing this. The prompt engineers are going to be sort of potentially could be the next frontier.
Excellent. Okay, that's awesome.
Dove, you didn't copy everything. You only copied the first part.
Okay, so apparently that was where the error was. Okay.
Yeah.
Okay, I know we are on the spot. We don't like to go beyond 5 minutes, but guys, give us extra 3 minutes to bounce so that you guys can enjoy your weekend. And honestly, guys, boy, I am just in awe. Can we give our love, give it up for Dr. Ekpe, please? Let's just do that real quick, everybody. You know what? I rarely do this, but let me unmute everybody so that we can just, you know, make some noise, go crazy, go all out insane on, you know, just unmute yourself and let's just appreciate him, man. This is
Thank you, sir. Dr. Ekpe.
Thank you very much.
Thank you, sir.
Thank you.
Thank you.
It's amazing.
Thank you, sir.
You did
Thank you,
an
Dr.
awesome
Ekpe.
job.
Thank you. Thank you.
Awesome job. Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you, doctor.
Thank you.
Thank you. Oh, I like that. I want you to show. Thank you. Thank you.
Thank you.
Awesome job. Okay. So, I mean, and one thing we just want to encourage is, I know Dr. Ekpe next week is going to kick off a program also. For those of us that want to be part of it, I think it's a solid space to be in. To be honest, you know, I have my brother here, Ziga, I have Yemi here, a lot of my folks that we've known each other for over 15 years, right? And one thing we would all agree is the world keeps evolving. We started with SAP implementation, product development work, audits, security, so many things evolving. Data is the new normal now. AI has taken over. Before you wake up, you realize, boy, you know, a lot of jobs will not be there again. And it makes sense to be a pioneer. I mean, I hope you've been upskilled, even within the last 2 days. I have been, to be honest. It's amazing. My thinking has changed and it has enhanced big time. So we have a class that is kicking off on Saturday. Be part of it if you can. I think it will transform your life and potentially someone's life. If you have someone that wants to take it, send them the link to ask them to register. Within the week also, we would have probably just like a Q&A short time. And I just sent the link to everybody. It's down there. If you want to register, go ahead and register. I'll send it to the regular group also, be part of it. We keep the group because it will be a place we keep updating you on data science kind of stuff, best practices, the new tools out there, new information that can impact our lives. collectively. So you'll see us send information to you that we think are relevant. And FYI, we close our group for a reason, to avoid spamming. Remember, again, we would never ask for money from you. We never ask for anything. So a lot of spammers online everywhere, right? So we don't do that, all right? So don't respond to anyone that asks you that somebody said this. No, we don't do that here, right? We just upskill, empower folks with the right tools, with the right knowledge. And before we wrap up, let's give some shout out to yourself also for spending the time. Give yourself an icon. At times we forget to appreciate ourselves, to be honest. I mean, not all of us can think of spending, look, 2 days, Friday night, Saturday morning. You want something bigger than yourself. 100%, I know that. There is no easy way to discuss it, really. Even for us that are instructors, we know how much we feel. It's a lot of sacrifice. Friday night, Saturday morning. Those are like the cream of the cream time for our personal rest. So thank you for being part of our community. We appreciate you. Let me leave the parting words to Dr. Ekpe. Please go ahead, Ekpe, and we wrap up.
Thank you, everyone, for your kind words and just being part of this and being patient. I am really excited and really thank you all. Hopefully, we get to see and engage some of you as we start the class next weekend. Thank you, and have a blessed rest of the weekend and blessed week.
Thank you, sir. I appreciate you, Ekpe. You're awesome, man. Thank you. And thank you, everybody. One love. You all take care. Bye.